Hello everyone and welcome to our part 2 presentation. The topic of this presentation today is risks in AI generating training data and the need of close supervision. My name is Paul Arsov and I'm the founder of the Decentralized Web project, but I'm going to talk about what we do in the end of this presentation, and let's come back right to the part 2 of this presentation. Last week we ended part 1 of this presentation with several questions. The first question that we asked is, how does AI becomes the arbiter of discrete knowledge or concepts? The other question we asked is, how can the AI judge in case of ambiguity and contradiction in order to establish the truth? The next question we asked is how it can create novel concepts and ideas. And the last question we asked is how does it reason about what it has experienced. There are in two general directions to take this line of inquiry. The first, which we mentioned in the previous presentation, is and it fits with the modern data science paradigm, is to assume that since truth is objective, all that is required is to filter, transform, and collate what is given in experiences into a data set. But since defining the data samples in question is always arbitrary, this approach, though intuitively appealing, is not viable. For example, there's no objective way to decide whether an outlier is valuable or if should be excluded. There are cases when we may want to include errors in our data sets, such as when the goal of the model is to detect those errors. The concepts that define the data are determined by the utility of the task in which it is being put. This leads us to the second option, which is to tie the definition of data sets to what is useful to the agent in question. The act of creating a data set is a cognitive task in itself. It can be performed better or worse according to some benchmark. We should therefore look at why the agent would engage this act to begin with. Creating a data set must have a goal or intention, such as to solve a business problem or to create a public resource other teams would find useful. This is the reason the US government is committing millions of dollars to creating these data sets. The nature of the data set will be determined by the task to which it will be applied. Data labeling is the process where the humans actually identify the object and then in a way that is understandable by the model, it informs the model. And so we have to actually label it in a very specific way. A data set is not just data, but structured data. For every value it contains, there is a property to which it is assigned, such as, For example, geospatial information, terrain type, or type of equipment. The choice of which property will be included or excluded and how each is defined and measured or is where the real work of translating continuous experiences into discrete data sets occurring. At every step in this process of creating data sets, how properties are defined and how they're selected, how they're measured and stored, there are decisions being made which entrench the reviewer or the person working on the data sets values into the outcome. And as many have noted, each step introduces the possibility for a bias. In fact, to say that a bias may be introduced is almost misleading. It implies the existence of a data set which does not contain biases. In reality, data sets are just artifacts that record our biases, where a bias is defined as the act of shaping the representation to suit our purposes or the purposes of a group or some kind of overarching goal. Well, when compiling a data set, we don't just invent a property from whole cloth and expect everyone to go along with it. It must be agreed upon beforehand as part of social disclosure. There's a communal act of definition at work here. We humans at some point decided to create concepts like location or asset. A dataset is a format of alignment between the teams who will use it and the creation of any explicit knowledge, including of datasets, is part of the larger act of communication. As data scientists, we rarely think of datasets as social artifacts, even though they must be so, since they're created in the social setting for communal purposes. Rather, we tend to look transparently through them as representations of truth. This cuts us off from determining how they could be created by an entity other than ourselves. By trying to remove the subject from the equation, like by trying to being objective, we end up removing the creator and thus making it impossible to understand and imitate the act of its creation. Few people have addressed this tension between reality and data, and the subjectivity entailed in every choice, as well as some like authors have noted. The information in the system is part of communication process among people. There's a flow of ideas from mind to mind. Data structures arise not by any natural law, but by the arbitrary decision of some human being, because the perception was useful to them and corresponded to the kinds of information they were interested in maintaining inside of the system. We are not modeling reality, but the way information about reality is processed by people. For an AI to define its own ground truth through act of an exploration, that truth must first be recognized as a subjective and inter-agent construct. It cannot come out of the raw data of experience itself. It must be created through the interactions of the agent with other agents. There are no fixed, static or objective data sets in the world of an agent. Each must have been motivated choice and subject to change when those motives change. Consequently, an agent would only be allowed to create their own data sets if there is trust between it and other agents, including humans, regarding the motivations that drive the selection. To this end, it must put in the effort to align itself as the result of us do, to mutually be agreed upon, to be reasonable, to this kind of standards of correctness. Since the underlying motive for defining the data set determines what will and will not be included, they must become good citizens before they become good curators of truth which can be included in a data set. Despite the potential benefits of this approach, it is of course largely neglected. We sense intuitively that the series of steps from an unbounded exploring agent to one that can compile and communicate its data sets will be long and costly. An AI with the mind of a toddler does not make for a good employee, and we don't have 18 years to wait on an investment that may or may not deliver. The long journey of laying down solid roots for intelligence is simply not cost effective. And so it is tempting to jump right to training at higher levels, leaving the dataset creation to us humans. These shortcuts will come at the expense of fragility, the inability for AI to adapt to unusual situations, and more importantly, at the cost of truly understanding what human cognition is. When large language models have nothing but our curated text and images to run on, they have no frame of context by which to correct their errors, to double check the wisdom they spill by holding it up to against the reality. Engagement with the real world is a set of skills from which we have shut it out. The important decisions were made before the AI even arrived on the scene, and any self-correction it does can only be done within the domain of the data it was given in the first place. It is no wonder that the resulting agents behave as children, hallucinating without self-restraint, making suggestions without measuring forethought, and we know grounding in the greater truth that surrounds them. And to be clear, what is useful is not random or unconditioned, it's tied to the reality and the causes the agent to define its utility. Um, Even when we have no intention of giving a data set to anyone except the agent being trained, we expect the benefit to be something others can ultimately understand. In this sense, AI are substitutes for humans. We communicate to both through datasets. And with this, I'm ending this part 2 of this presentation. And I like to come back to the beginning of this presentation um, uh, when I told you that my name is Paul Arsov, and I'm the founder of the Decentralized Web project. Currently, we're working on 3 different projects, and like I like to mention one after another, all these 3 projects. The first project that I want to mention is a marketplace and collection of NFTs. And what is interesting, unique, and special about these NFTs is that they are based on 3-dimensional objects. With 3-dimensional objects, there has to be special software which reads the file of the 3D object. Then it displays this file in a window, and then it can do some manipulations of this 3D object, like moving it, rotating it, zooming in and out, and etc. In general, creators of 3D objects, they are accustomed to use standard software, and currently there are 2 very popular choices for 3D object creators. The first kind of software they use is game engine called Unity, and the second kind of software for displaying of 3D objects that creators can use is called Unreal, and it is also a game engine. But from the very beginning in our project, we decided to build our own 3D software engine, and what it does is it reads the file of the 3D object, then it opens window on a computer screen, it loads the 3D object file, and then it starts animating this object in a way of moving it around the window in a random fashion. But in addition to these basic initial capabilities of a reading file, opening a window, and animating of 3D object, our 3D software engine has multiple additional capabilities. The first additional capability of our 3D software engine is the capability of speaking. Our 3D NFTs can speak in one of 3 basic voices. The 3D NFTs can speak either in a male voice, or in a female voice, or in a whisper kind of a voice. In addition to the 3 basic voices, there are 3 different flavors of voices. A voice can be spoken either in a normal speed manner, or in a fast speed manner, or in a slow speed manner. And if we take a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a very masculine person, or the voice of an old person. If on the other hand we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a little girl, or the voice of a funny person. The second additional important capability of our 3D software engine is the capability of voice recognition. Like currently, if we have a 3D NFT which is animated by the way of constantly moving around the window, then we can issue our very first voice command to this 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. We can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go farther away, zoom out, and start rotating. The next additional and important capability of our 3D NFTs and 3D software engine is of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply with in few sentences about who they are. You can ask the 3D NFT to describe something. For example, describe Web3, or describe decentralization, or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3, or about decentralization, or about the country called Russia. The last additional and important capability for our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or bluish colors. Then you can come to our 3D NFT marketplace, and probably now is the time to tell you the name and the URL of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3dnft is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is altogether 3D NFT. Then there is dot, then there are two words, and they're typed all together: decentralized and web, and their type decentralized web. Then there is dot, and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of the main page and every other page, there are number of links, and one of these links is going to point to accessories. You can click on this link, and then you're going to see that we are offering special glasses. You can click on the button to continue, make a payment, and order one piece of these glasses. And when you receive these glasses, you're going to see that one lens of these glasses is red, and the other lens of these glasses is blue. You can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and then you're going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D NFTs collection and 3D NFT software engine, but I like to mention a little bit about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance, and this blockchain instance runs Ethereum software. This is the same software which runs on Ethereum mainnet. It runs on Binance Smart Chain. It runs on Avalanche AVAX chain. It runs on Polygon Matic chain, and it runs on many other well-known and not so well-known blockchains. By having our own blockchain instance, then we do not need to charge our users to pay gas fees for deployments of the smart contracts for the non-fungible tokens, and our users do not pay fees for transactions of transfer of ownership from one user to another user. By having our own blockchain instance, we also our users to pay for the purchase and then receive proceedings from sale in multiple crypto coins. Currently, the choices include 4 different coins, which include Solana Sol, Polygon Matic, Avalanche AVAX, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. With this, in addition to these choices of buying and receiving proceedings from sale in crypto, we have a second parallel and independent way of buying and receiving proceedings from sale of our 3D NFTs, and it is done entirely in fiat currency. I can give an example with, let's say you come to our 3D NFT marketplace, you click and browse through our 3D NFTs, and let's say you see a 3D NFT that you like to purchase. Like when you click on this 3D NFT, then you're going to see a short video of this 3D NFT as it is moving, and then you're going to see a drop-down menu which is asking you to select a way of payment. The choices include 4 different choices of payment with crypto, and a 5th choice of payment with fiat currency. So let's say you click and select this 5th choice, and then you are going to be going into a screen where you have to put the number of your debit or credit card, expiration date, CVC, and when you click on the button to make the payment, what is going to happen is there is going to be a transaction and conversion from your national fiat currency to US dollars, and this transaction and transfer is going to be deposited in our bank account. We are going to follow this first action with the second action, and this is going to be a transaction of transfer of ownership from the initial ownership from our 3D NFT marketplace to you, and now you become the owner of this 3D NFT. You can play with this 3D NFT for a while, and then you can decide to put this 3D NFT for sale. Then what is going to happen is, let's say there's a second user, they come to our 3D NFT marketplace, they browse through the collection of the 3D NFTs, and let's say they specifically like the 3D NFT that you put for sale. So what they're going to do is they're going to click on this 3D NFT. They're going to be presented with choices of payment with crypto or payment with fiat currency. So let's say they select payment with fiat currency, and they put their debit or credit card. They click on the button to make the payment, and what is going to happen is there's going to be a conversion from the national fiat currency of the second user, which could be different than your national fiat currency and different than US dollars. And this transaction is going to be converted to US dollars and deposited in our bank account. Then we're going to follow this action with a transaction of transfer of ownership from you, the current user, to the second user, which they purchased this 3D NFT, and now they become the owner of this 3D NFT. We are going to follow this second action with the third action, and transfer and conversion from US dollars to your national fiat currency, and this transfer is going to be deposited in your bank account. With this said, I'm ending talking about this first project. I'd like to mention a second project that we are working on, and this second project is related with electric vehicles and making products which can switch high current electric power, whether it is going to electric vehicle or not. And these products that we're making, they're going to be remote controlled, and they're going to include a near field communication reader. But why we did decide to make such products, and why we're developing and creating such products? In the near and rapidly upcoming future, there is going to be exponentially growing number of electric vehicles, and these electric vehicles would be needing charging. Currently, the charging of these electric vehicles is done in a way of similar to the way internal combustion engine vehicles. They're coming to special locations called gas stations where there are a number of columns, and the internal combustion engine vehicles, they stop at the column, they connect hose and pipe to their gas tank, they start loading gas, they identify themselves by their way of payment, debit or credit card, or they go to the convenience store of this gas station and they pay cash. Then after they load fuel in their vehicle, then they leave this gas station. In the same way, they're similar to gas stations locations where there are number of columns, limited number of columns. Electric vehicles, they come to these locations, they stop by, they connect the electric cable to their vehicle, they identify themselves with their debit credit card or some token, they start charging their electric vehicle, they stay for a period of time, and at some point they disconnect the cable, and they leave with their electric vehicle which was charged with certain amount of electric energy. But like we estimate and we make projection for the future that the number of these electric charging stations is going to become ultimately insufficient to charge the rapidly growing number of electric vehicles. And to handle the case of exponentially growing electric vehicles, we are proposing a model which resembles the which we call it a parking lot model, where the electric vehicle coming to a parking lot, and this parking lot can be the place of living of the user if they are living in a high-rise building, and there is a ground floor dedicated for parking, or there is ground floor and multiple underground floors dedicated for parking of this high-rise apartment building. Or the parking lot could be the place of work of this user if user works in a high-rise building, and this high-rise building in the same way has a ground floor and or several underground floor dedicated to parking lot. In the same way, like the user can charge their vehicle at the place of living during the time they leave their vehicle at the place of living, which could be like evening time, night time, and early morning. And in the place of work, they can charge their vehicle at morning, noon, and afternoon, and maybe sometimes early evening times at the place of their work. With this said, I like to invite you to read the article regarding this model that I just described, and it is going to tell you much more details about the different models and the product that we're building. And the product that we're building includes high energy electric switch. It includes remote control capability with through internet connection. It includes near field communication reader, which can identify the debit, the credit card, or a token of the or a near field communication token, which could be with the credit card size, or it could be a keychain token, or even it could be a ring which the user can be wearing, and they can identify themselves to the near field communication reader. But this is not going to be a single product device. All of these devices, they can form a connection with other devices which are mounted in the same parking lot. They can communicate with each other, and also they can report the events like start, stop of charging, amount of electric power charged, and like calculate the total amount of electric vehicle, because buildings, they have like especially business building, they have certain envelope of electric energy they can consume, and when they exceed this envelope of electric energy consumption, they have to pay rates of penalty penalty fee rates for the electric energy. So business locations, they have to be specifically careful about the electric energy they could provide for the users in their building and residents of their building, and also electric utilities, they can be notified about specific requests for charging of energy and aggregated demand for requests to demand this certain number of electric energy. This is very, very important for electric utilities because the generating capabilities has at all times to match the consumption capability of for the users, and if there is some disbalance between generation and consumption, this can lead to blackouts and turning off of the energy, so that electric utility can bring additional generating capabilities or reduce the generating capabilities, but this takes time to achieve generation increase or reduction. With this said, I like to tell you the name and the URL of this second project that we work on. It is power.rstack.com. Power is the ordinary work for power, then there's dot, then there something which sounds like rstack, and I can spell it letter by letter. It's Alpha, Robert, Sam, Tom, Echo, Charlie, Hotel. Altogether, it's rstack, then there's dot, then and it ends with com. With this said, I'm ending talking about the second project. I'd like to tell you about the third project that we work on, and this project is called Elements of Artificial General Intelligence. Currently, it is assumed that artificial intelligence is based on large language models and machine learning. But it is my personal opinion that statistics-based ways which are employing the technique of machine learning, and which then they're producing large language models, or models which can generate images, or models which have additional other purposes. I like to use the metaphor that these models and programs which are using these models are something like a mirror. If we humans look at the mirror, we can see ourselves, and what we see is a reflection which looks human-like. In the same way, programs which are using large language models, they arrange words in a way that resembles what we see in a mirror. What we see or what we hear as produced by a large language model makes sense, but in my personal opinion, it is just a reflection, and it is not true thinking, or true meaning created. So with this said, what we're working in this third project is putting together diverse elements into a single engine, and this engine is going to include voice recognition, voice synthesis, It is include computer vision, and it is going to include multiple additional other capabilities. Currently, at this moment, we're working on um, machine vision, and specifically what we're working is identifying one or more specific objects in real-time video. Let's say this web camera. This camera is continuously recording. It is continuously streaming number of frames, and in these frames, like the first thing, we have to recognize certain number of objects, and then we have to do tracking of these objects uh, regardless of whether like we see the object from the side or we see object from the front, or regardless of this object is close or it is very far away. So we have to achieve continuous tracking, and this is very, very important and kind of a life and death situation for an autonomous device. If this device have to go and find a charging station, and they have to, like when they are low on like electric power, they have to find within a certain location and within certain room where is the charging station, and they have to move towards this charging station, and they have to then come in close proximity and or connect themselves to these electric charging stations. So this is very, very important thing for autonomous device, and it is life and death situation which has to be resolved for an autonomous and robotics device. With this said, I'm ending talking about this third project. We still do not have released the website, but we are going to prepare probably a GitHub location where we're going to put releases for users to evaluate, and we're going to build a website and record a number of videos which are explaining what we are doing. With this said, thank you for viewing, thank you for listening. Have a nice day, have a nice evening, and goodbye.